Hello students, how are you all? I hope everyone fine. So today we will continue the properties of binary operation. In last video we completed three properties: commutative property, associative property, as well as identity property. So the fourth one, inverse property. Okay, see, let me first define what I mean by inverse of an element. If inverse exists for all the elements of the given set, then inverse property holds. So you should know how to find out inverse of an element. See, the definition is as follows: an element A inverse, and there is a notation you saw already in an inverse trigonometry function, inverse of a function, inverse of an element, okay, will be denoted like this. And an A inverse belongs to S is called an inverse of an element A belongs to S if, what is S here? S is a non-empty set. So okay, if A star A inverse is equal to A inverse star A equal to E. What is E here? E is nothing but identity element of S. E is the identity element of S. So if this condition satisfies for an element A belongs to S, then we say that inverse of A is A power minus 1 or A inverse. Okay, see, as example, usually we will understand this definition through examples only. Again, I'll explain the same sentence by an example. Okay, with respect to addition, which number you should add, okay, so that the resultant is identity element of addition. What is the identity element of addition? You know that, 0. Perfect. Tell me which element I should add. Yeah, perfect, you know, minus A. So therefore, with respect to addition, inverse of A is minus A. Not only this, see, this is also equal to minus A plus A is also equal to, you know, 0 alva. So remember, with respect to addition or additive inverse, maybe you heard, additive inverse is minus A. Matrices all nodidire atho lower classes all kelidire, additive inverse is minus A. Adhe tara multiplicative inverse, which number I should multiply so that the resultant is identity element with respect to multiplication. What is the identity element with respect to multiplication? Yeah, 1, which we solved, okay, which we learned in the last video. Now which element we should multiply? Yeah, we should multiply 1 by A. So this implies I can write A power minus 1 is equal to 1 by A. So multiplicative inverse of an element is always 1 by A. Additive inverse of A is minus A. Correct? Information. So I hope you understood the definition through this example. We are going to solve problems later, don't worry, where you are going to find out, you know, inverse of an element when the operation is other than addition and multiplication. Okay, so I hope this much you understood. So definition now I will give you a note which define what I mean by inverse property. If inverse of A exists for all A belongs to S, then okay, binary operation star, then binary operation star satisfies inverse property really on S. If inverse exists for all the elements, every element of the non-empty set S, then we say that inverse property holds with respect to this on this set. So sometimes what will happen, inverse will be exist for one single element or maybe 10 elements out of 12. 10 elements exist but 11 and 12 does not exist. So in that case, inverse does not exist. So one element inverse illa antadre, inverse does not exist. Please remember that. Okay. So now based on the definition of binary operation, properties of binary operation, yaudella property kaltito? Yes, or commutative, associative, identity and inverse. Based on these concepts, we are going to solve some problems. These are the very simple problems, okay, logical thinking, simple agide. So we are going to solve some very simple basic problems on these concepts, okay. Yes, the first question, determine whether or not each of the definition of star given below gives a binary operation. Andre we have to check whether this operation is binary operation or not. We already solved so many examples under the definition of binary operation. You may know how to check this, but again I will recall, okay, how to check whether this is binary operation or not. Okay, first ಏನು ನೋಟ್ ಮಾಡಬೇಕು, ಸೆಟ್ ಯಾವುದನ್ನು ನೋಟ್ ಮಾಡಬೇಕು. ವಾಟ್ ಇಸ್ ದ ಸೆಟ್ ಹಿಯರ್? z plus and then positive integer. Okay, so now you have to check whether unique a star b equal to ab. Okay, we have to check whether this is belongs to z plus for all a comma b belongs to z plus. If this is true, then star is a binary operation. If this is not true, then you should give one example to prove it is not true. Then write star is not binary operation. If we multiply two positive integer, what will be the resultant? Obvious, it must be positive integer, alva. So this is true. You will not get here negative integer because input is positive integer. Other than integer is also not possible because multiplication of every two positive integer is always a positive integer, and it will be always unique condition. As I told in the previous video, it never fails. Almost 99.99% never fails in any problems, but usually either conditions fail agate. But product of positive integer is a positive integer always for all the positive integers, so it is true. So this is true. So therefore star is a binary operation. Artha aita heltirodu, star is a binary operation. Clear aita? Next problem, same heading. You have to check whether the given star is binary operation or not. The set is real number, operation is defined like this. Can you tell me whether this is binary operation or not? Only you have to check whether unique a star b andre enili ab square belongs to r for all a comma b belongs to r. Whether this is true or not, you have to check. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳ್ತಿರೋದು? You have to check whether this is true or not. If you find for some example this is not true, you write down that example and write it is not true. One example is enough to prove it is not true. ಅರ್ಥ ಆಯ್ತಾ? ನೆನಪಿರಲಿ, one example is also enough to prove it is not true. So first you analyze unique condition. Nothing to worry about the unique condition. The a is a real number, alva. B is a real number, mandre b square is also real number. Product of two real number is definitely a real number. Did you agree with this explanation? Correct, alva. Now idu yavaga real number agala heli? Denominator 0 agidare. Denominator 0 ide alli. Denominator 0 ago chance idya? No way, because denominator is 1. Innond case yavud heli? Square root of present and then imaginary number baro chance idya? Imaginary number baro chance idya? Square root idya? Square ide, not an issue. Square root idya? Illa. So at any cost, for every integer, for every real number, adu 0 agirli, whatever it may be, this cannot be other than real number. Illi negative square root of negative number baro chance illa, denominator 0 ago chance illa. So it's perfectly real number for all real numbers. ಅರ್ಥ ಆಯ್ತು ಹೇಳ್ತಿರೋದು? ಇದು ನೆಗೆಟಿವ್ ನಾಟ್ ಎ ರಿಯಲ್ ನಂಬರ್ ಅಂತ ಹೇಳೋ ಚಾನ್ಸ್ ಇಲ್ಲ. ಎಕ್ಸಾಂಪಲ್ಸು ಸಿಕ್ಕಲ್ಲ. ಸೊ ವಾಟ್ ಇಸ್ ದ ಕನ್ಕ್ಲೂಷನ್? ದಿಸ್ ಇಸ್ ದ ಆನ್ಸರ್. therefore star is a binary operation. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? therefore star is a binary operation because this product of two real number is always real number. Okay, and b square definitely it will not trouble you. Okay, fine. Next, one more question. On z plus, define star by a star b is equal to mod of a minus b. Again we have to check whether this is a binary operation or not. So again same argument, take a unique, write the definition of binary operation and check whether it holds for all. Okay, yes, z plus for all a comma b belongs to z plus. Okay, now because of this modulus sign, one thing is very clear, because of that modulus sign, it's very clear that the output cannot be negative. So z plus the problem illa, 100% it belongs to plus and the positive integer. But now you have to check whether the a minus b is always an integer. When you subtract two integer is always an integer, alva. When you subtract two integer, always an integer. You'll see, suppose a is equal to 2, b is equal to 3, then 2 star 3 ಏನಾಗತ್ತೆ ಹೇಳಿ? mod of 2 minus 3. ಇದು is it belongs to Z plus? Yes. Why it should belong to Z plus? Yeah, 2 minus 3 is negative, but because of modular sign, that negative sign does not come out. So remember, this is true again for all a comma b belongs to Z. Therefore star is a binary operation. Star is a binary operation. So after defining binary operation, I took some example where you got to answer as most of the answer as not a binary operation. So I took here 3 problems with the binary operation. So not a binary operation banದಾಗ example ಬೇಕಂತಿಲ್ಲ, just I explain. Okay, is directly right. If you come to know that it is true always, then right, it is a binary operation. Clear? ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? Very good. Okay, so this is a one type of problem. 1 marks kilo chance ಇದೆ. Define, check whether the following given operation is binary operation or not. This is important. Next type of question, okay, in this exercise is check whether the given binary operation is commutative or not. ಇಲ್ಲಿ binary operation ಹೌದು ಚೆಕ್ ಮಾಡಬೇಕಂತಿಲ್ಲ. It's already given that it is a binary operation. Only how to check whether it is commutative or not. ಅರ್ಥ ಆಯ್ತಾ? Or associative or not. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್. ಇದು 3 ಮಾರ್ಕ್ಸ್ ಕೇಳೋ ಚಾನ್ಸ್ ಇದೆ. ತುಂಬಾ ಈಸಿಯಾಗಿ ಆನ್ಸರ್ ಮಾಡಬಹುದು. ಸೊ at any cost ಇಂಥ ಕ್ವಶನ್ಸ್ ಬಂದಾಗ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬಿಡಬೇಡಿ. ಈಸಿಯಲ್ಲಿ ಆನ್ಸರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುತ್ತೆ. ಫಾರ್ಮುಲಾಸ್ ಇಲ್ಲ, ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಜಾಸ್ತಿ ಬರಲ್ಲ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಇರಲ್ಲ. ಸೊ ಈಸಿ ಟು ಸ್ಕೋರ್ ಮಾರ್ಕ್ಸ್. ಓಕೆ, when the question asks of this kind in final exam. Okay, so first question ಏನ್ ಚೆಕ್ ಮಾಡಬೇಕು? ಕಾಂಪಿಟೇಟಿವ್ ಮತ್ತೆ ಅಸೋಸಿಯೇಟಿವ್ ಹೌದಾ ಅಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು. Okay, the first question is on set of all real number a star b is equal to ab plus 1. First ಏನ್ ಚೆಕ್ ಮಾಡಬೇಕು? We have to check whether it is commutative or not. ನೆನಪಿದೆ ಡೆಫಿನೇಷನ್? ಏನು ಡೆಫಿನೇಷನ್? a star b if it is equal to b star a for all a comma b, then it is commutative. Okay, so let me find out first a star b. A star b is given ab plus 1. Confusion illa, kottadanu bariyodu as it is. Now if this is a star b, what is b star a? ಏನಾಗಬೇಕು ಹೇಳಿ? a ಇದ್ದಲ್ಲಿ b ಆಗುತ್ತೆ, b ಇದ್ದಲ್ಲಿ a ಆಗುತ್ತೆ. So it become ba plus 1. Now check whether these two are equal or not. Okay, so from these two, what you can write? Tell me. From these two, ಎರಡು ಒಂದೇ ಅಲ್ವಾ? This is also equal to ab plus 1. There is no change. ba is equal to ab, not an issue. So ab plus 1. So you can write a star b is equal to b star a. So if this condition satisfies, what is the conclusion? Star is commutative. Therefore star is commutative. So for the first problem, we proved that it is commutative. Now we have to check whether it is associative or not. We have to check whether it is associative or not. So associative condition ನೆನಪಿದೆಯಾ? What is the condition? Okay, ಇಲ್ಲಿ ರಫ್ ಆಗಿ ಬರೀತೆ ನೋಡಿ. a star b star c. We have to prove that a star b star c. When you pronounce it look like same, but okay, presentation is different. So take the first one, a star b star c. Correct? A star. What is b star c? A star b ಇದಾದ್ರೆ b star c ಏನಾಗುತ್ತೆ ಹೇಳಿ? bc plus 1. ಕರೆಕ್ಟಾ? ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? Now take this as a z. ಯಾವುದನ್ನ? ಇದನ್ನ z ಅಂತ. So where z is equal to bc plus 1. So now if a star b is equal to ab plus 1, what is a star z? a z plus 1 ಅಂದ್ರೆ a into z ಅಂದ್ರೆ bc plus 1 plus 1. So ಏನಾಗುತ್ತೆ ಇದು? a b c plus a plus 1. Let it be 1. One side ಆಯ್ತು. ಯಾವುದು? a star b star c ಆಯ್ತು. Okay, next you consider a star b star c. ಇದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. a star b ab plus 1. ಕರೆಕ್ಟಾ? It is given. Take this as a z. Okay, where z is equal to ab plus 1. So now what is z star c? Z star c is zc plus 1. Correct? zc plus 1. Z ಅಂದ್ರೆ ab plus 1 into c plus 1. So ಇದೇನಾಗುತ್ತೆ? abc plus c plus 1. Name this as a 2. Now check whether 1 and 2 are equal. ಎರಡು ಒಂದೇ ಇದೆಯಾ? ಇದು 2, ಇದು 1. abc, okay, abc fine. Plus 1 is okay, but see, a is here, a here, c. So it is very clear that their known it should be equal. So therefore from 1 and 2, what we check? a star b star c is not equal to a star b star c. Therefore star is not associative. Therefore star is not associative. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? Therefore star is not associative because the condition fails. Which condition? A star B star C is not equal to A star B star C. Reason ಏನು? ಇಲ್ಲಿ A ಇದೆ, ಇಲ್ಲಿ C ಇದೆ, ಅಷ್ಟೇ ಡಿಫರೆನ್ಸ್. ಮತ್ತೆಲ್ಲ ಅದೇ ತರ ಇತ್ತು, ಬಟ್ ಅದು ಒಂದು ಟರ್ಮ್ ಡಿಫರೆಂಟ್ ಇದೆ. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಇಟ್ is not associative. Confirm? Understood? Very good. Next. Again same work, we have to check whether it is commutative or not, associative or not. This is an interesting question. Observe this carefully. Okay, let me verify first whether it is commutative or not. You can try, okay, definitely you can try yourself, no need to wait for my solution. First A star B ಏನು ಮಾಡಬೇಕು? ಸಿ ನಿಮ್ಗೆ ಇದು ಫಸ್ಟ್ ಅದು ಅರ್ಥ ಆಗಿದ್ರೆ ಈ ವಿಡಿಯೋ ನೋಡೋದಕ್ಕೆ ಪಾಸ್ ಮಾಡಿ, ಕ್ವಶನ್ ಬಂದಮೇಲೆ ಪಾಸ್ ಮಾಡಿ ಟ್ರೈ ಮಾಡಿ ಒಂದ್ಸಲ. Okay, nimge ಏನು ಆನ್ಸರ್ ಬರಲಿ, don't worry about that, because anyway I'm going to solve after getting some answer, okay, in your capacity, okay, in your notebook. Then play again, you will come to know whether you did properly or not. Suppose you are able to get answer yourself perfectly, that will give different confidence to you. Understood what I am telling? ಇದೇ ಪ್ರಾಬ್ಲಮ್ ಇದೆ, ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ಗೂ ಅಷ್ಟೇ ನನಗಿಂತ ಮುಂಚೆ ನೀವು ಮಾಡ್ಬೇಕಂತಿದ್ರೆ you can, how, pause the video. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? ನೆನಪಲ್ಲಿ. ಸೊ ನಾವು ಚೆಕ್ ವಾಟ್ ಇಸ್ A star B, 2 power AB, ಕರೆಕ್ಟಾ? ಇಲ್ಲಿ ಏನು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಇಲ್ಲ, ಇದನ್ನು ಹಾಗೆ ಬರೆಯೋದು, ನಥಿಂಗ್ ಟು ವರಿ. ನೆಕ್ಸ್ಟ್ B star A, 2 power ಏನಾಗುತ್ತೆ BA. ಇದೆರಡರಲ್ಲಿ ಚೇಂಜಸ್ ಕಾಣುತ್ತೆ ನಿಮಗೆ. 2 power AB is equal to 2 power B ಅನ್ನೋ. ಓಕೆ, ಸೊ ಫ್ರಮ್ 1 and 2 ಏನು ಬರೀಬೋದು? ಫ್ರಮ್ 1 and 2 A star B is equal to B star A. Therefore star is commutative. For star is commutative. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? ವೆರಿ ಗುಡ್. ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್, commutative is over, right? ನೆಕ್ಸ್ಟ್ ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕು? we have to check whether it is associative or not. Okay, you have to check whether it is associative or not. Same conditions we have to verify. So first ಅದೇನು? A star B star C, it is A star B. B star C ಏನಾಗುತ್ತೆ? ಇದು A star B ಆದ್ರೆ B star C ಏನು? 2 power BC, ಕರೆಕ್ಟಾ? 2 power AB ಇದ್ದದ್ದು 2 power BC ಆಗುತ್ತೆ. ಸೊ ಯು ಟೇಕ್ ದಿಸ್ as Z. ಓಕೆ, ಯು ಟೇಕ್ ದಿಸ್ as Z. 2 power BC ಅನ್ನ Z ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಸೊ A star Z ಏನು? ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ 2 power AZ ಅಲ್ವಾ? 2 power AZ, that is 2 power A. What is Z? 2 power BC. ಸೊ ಏನಾಗುತ್ತೆ? 2 power ಅಷ್ಟೇ, ಇದಕ್ಕೇನು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಪಾಸಿಬಲ್ ಇಲ್ಲ. ಓಕೆ, ಸೊ 2 power A into 2 power BC. ಸೊ ಲೆಟ್ ಇಟ್ ಬಿ 1. ಇನ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ನೆನಪಿರಲಿ. ನೆಕ್ಸ್ಟ್ ಕಂಡೀಷನ್, A star B star C. A star B ಏನು? 2 power AB star C, ಕರೆಕ್ಟಾ? ಟೇಕ್ ದಿಸ್ as Z. Again same procedure, 2 power ZC, right? 2 power Z ಅಂದ್ರೇನು? 2 power AB into C. ಇಲ್ಲಿಯೂ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಆಗಲ್ಲ. So let it be as it is. So what is the conclusion? Whether they are equal or not. 2 power A into 2 power BC, is it equal to 2 power BC into C? Definitely no. From 1 and 2, A star B star C is not equal to A star B star C. Therefore star is again not associative. It is commutative but not associative. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? ಸೊ ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಕನ್ಫ್ಯೂಷನ್ ಇದ್ರೆ you pause and replay, or okay, or you can discuss with me later in through WhatsApp number. So but ಇಂಥ questions ತುಂಬಾ important, easily answer ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುತ್ತೆ, ನೆನಪಿರಲಿ. Okay, the one more question, the last question for this video is on Z plus A star B is equal to A to the power B. A to the power B. First ಏನು ಚೆಕ್ ಮಾಡಬೇಕು? commutative property. ಇದು ಈಸಿ ಇದೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಕ್ಲಿಯರ್ ಆಗಿ. We have to check whether it is commutative or not. A star B is equal to A to the power B, correct? B star A equal to B to the power A. Whether they are equal? Is it 2 power 4 is equal to 4 power 2? Definitely not. So from these two, what we can write? Star is not commutative. Star is not commutative. Artha aita heltirodu? So star is not commutative. Now what we have to check? Associative or not. So first you have to check A star B star C. This you have to check, right? That is A star B power C, correct? So now this will be equal to see a power b allo, this is a, this is b. Now ಏನಾಗತ್ತೆ ಹೇಳಿ, a power b power c, ಇದು ಒಂದು first side. A star b star c is equal to a power b power c. Next a star b star c, ಇದೇನಾಗತ್ತೆ a power a star b ಅಂದ್ರೆ a power b star c, correct? So this will be a power b power c. ಇದನ್ನ ಹೇಗೆ ಬರೀಬಹುದು, you can write this as a power bc. This is 2. Whether these two are equal? Definitely no. So again what you got, star is not commutative, because not associative, because again the same condition fails. So we proved 3 problems under the heading the commutative or not. So it will continue in next video. Thank you.